There's very little you can mess up from the front panel. It's one thing I like about it. One button, basically for information only. You can't turn the controller on or off or change any set points with the cover on. You have to remove the cover to force the system on or to change the set points, which should never have to be changed ever, ever, ever.
Say that again. And set
never
points?
change the set points. The set points are typical right now, which is that it has a turn-on differential of 16 degrees. That is, the difference between the solar tank and the collectors has to be 16 degrees before it turns on, and it has a high limit of 140. The tank manufacturer for the storage tank is saying 140 is the maximum, and the tank manufacturer for the drainback reservoir is also saying that 140 should be the maximum stored in that tank for the longevity of the tank. You can store higher temperatures in there, but it takes a toll over the years and results in a shorter tank life, so 140 is the compromised temperature. I'll go through the screens on this. The top line, COL and STO, will always be there. The top line, COL, is the collector temperature. It's where that sensor is in the upper west side of the array, showing 98 degrees. It's morning. We're only just now getting a little sun. We're not warm enough to turn on. STO is the storage tank temperature, showing about 120 degrees. That's heat left over from yesterday. Hasn't been used up, and the tanks are pretty well insulated. Picture them as giant thermoses, and they'll hold that heat for many days, many cloudy days. pKh and pKl are really diagnosis numbers. They indicate the maximum and minimum temperature since the controller was last reset, and I can reset those. If you hold down the button, you'll see they reset to the current temperature, and that way you can monitor, like, okay, how did I do during the day? This page is the most important page, and this is the most important number in the controller. Unlike all the other numbers, this number tells you definitively that the solar is actually doing something. This number is a cumulative total, kilowatt hours. While we're collecting thermal energy, it's displayed as kilowatt hours, which is becoming the standard for measuring energy versus BTUs. And the controller is converting BTUs to kilowatt hours. It's very accurate. It's within 2% accurate of the energy being collected. And this number should increase on every sunny day. You can write down the number at the beginning of a month and check the number at the end of the month. And this time of year, you should see somewhere around, based on the hot water load here, somewhere around a 10 kilowatt hour a day increase. If this number doesn't move, the system's not working, something's wrong, and you need to call for service. Okay, next page is GPM. That's the flow rate in gallons per minute from the pulse flow meter, which is located on the collector plumbing behind the drainback reservoir. It's at 0. We're not running. Any flow at all will show up on here, including when it drains back. It'll tell you the flow of the drain back, which is an interesting piece of information I've never had access to before.
And go over again why it's not running, just because people might miss that.
The reason it's not running is collector is less than storage. So if we ran right now, we'd dump heat into the atmosphere.
We don't want to
do that. So as long as collector is less than storage, it will not run. There are some other circumstances where it will not run. In the winter time, if the temperature of the collector is less than 50 degrees, even if we have a 40-degree tank, which I think we will in the winter because we have such cold water, such cold ground temperatures here, it will not run. So the controller is preset that if the collector is less than 50 degrees, it will not run. In addition, we have redundant freeze protection on this. We have a separate system that is watching the temperature of the plumbing in the attic. specifically the plumbing before what's called the collector return line. The cold water from the Drainback reservoir has a switch on it that opens up if it hits 40 degrees. And this will completely disable the pump. You cannot force the pump to run. You cannot trick the controller into running the pump. If the freeze protection comes on, it will completely lock out the system until that plumbing exceeds 40 degrees. And that's to prevent things like people putting this controller into manual mode in the winter and freezing the system. So it's kind of our extra safety. AX3 is not connected. It's an optional tank temp sensor. AX1 and AX2 are our BTU meter sensors. AX1 is the high temp and AX2 is the low temp. The combination of GPM, solar supply temperature, and solar return temperature gives you energy. You can derive energy from those three numbers. And the controller does all the math for you, so don't have to worry about doing the math. When the system's running, AX1, the solar supply temp, should be warmer than AX2. If it's not, then there's either a problem with the sensors or a problem with the controller. You may never see that. We never see that. It's not something I'm saying you should check. And you may notice sometimes that it runs with a very slight differential. For example, 77 degrees on the solar return and 78 degrees on the solar supply. One thing to keep in mind is we're running about 8 GPM. So even 1 degree difference on those sensors represents a fair amount of energy at 8 GPM. Let's see. These are preset numbers: differential, diff, and HIL, high limit. There are knobs inside here to set those, and those should be left alone. Light will flash when the controller is thinking about running the pump. So if there's a little pre-delay before it starts running, and it'll start flashing that light, and then it will activate the pump. The upper limit light will turn on when we reach the upper limit, which is the high limit. In this case, it's 140 degrees. The fault light is probably the most important light here. The fault light indicates that the controller is getting an erroneous reading from a sensor. If a sensor has become disconnected, or the wires are shorted, or the sensor readings just don't make sense. Also, if this controller, if you take this cover off and you force the system on, the fault light will turn on, kind of as a reminder that, hey, the system's being forced on or off. You know, it's not on automatic. So not every fault requires a phone call. Mm-hmm. Sometimes it could be the switch inside. And it will tell you, at the bottom line, it will tell you what the fault is. It will tell you which sensor is shorted or closed, and it will tell you if the pump switch is on. When the system runs, the controller will send power to our freeze protection relay. The power light will come on. The freeze protection relay then checks the status of the freeze switch up in the attic. That will turn the relay on in here in zone 1. The zone 1 light will come on, indicating that it's sending power through. And then the power goes to the pump and the pump turns on. If the power light comes on and the zone 1 light does not come on, that indicates that the snap switch is opened in the attic, or possibly there's a problem with the wiring. If it's not cold and the zone 1 light fails to come on, then there could be a problem with the wiring to the snap switch. You may never see that. It's not something I'm advocating checking for. It's kind of fail-safe in that way, in that a failure will not cause the system to run when it shouldn't. Okay, I'm going to move to the second controller. This is an independent system of these. You can see they're not connected in any way. The gold line controller is a simple differential controller. A differential controller checks temperatures on two different sensors, and if one sensor exceeds the other by a preset amount, in this case 8 degrees, it will power a pump. And so what it's doing is it is checking the temperature of this coil here at the bottom versus the temperature of this tank. There's a sensor inside here. Those two sensors are connected to the controller. I'll go over the lights real quick on this controller. There's nothing worth adjusting in here. And all the adjustments are behind the cover, which means that you shouldn't touch them. The first light is power, which should always be on. The second light indicates that the pump is being energized. So right now it's running. It's moving heat from the solar Drainback reservoir into the storage tank. The third light will never come on. That's for freeze protection, and it doesn't apply in this case.
So you can see the second storage tank is at about 120, and you can see the temperature of the Drainback tank on the controller under STO, and it's about 120 as well. This afternoon, collector temperature should be very hot, and if there hasn't been demand, the system may be high limited because there's already enough hot water that's been generated. Here we are in the control room of the north building, which we just looked at. You can see the collector temperature is 254 degrees. The storage temperature in the tank is 140. So the system is not running. The upper limit light is on. The upper limit light right here is on because the system is high limited. The pump is not operating. The gallons per minute is 0.
Well, I gotta think hard about this. Checking the water level on the Drainback reservoir. First thing, unplug the controller. Good time to check it is in the morning when the system isn't running. If the system's running, you gotta wait about 6.5 minutes for it to drain back into the tank. Okay, the next step is get the handy-dandy solar fill hose out here. And connect it up to this top drain.